Hi class, welcome to exercise 2.5. I wanted to give you guys an opportunity to see a part produced in completion. So this is a fairly accurate representation of how I would make this part on my machine here. So we start out with the left vise being op1. You could do either left or right as op1, but I'll typically go left to right. So I'll start with the left vise being op1, and you can see our part is in the vise. And then on our second operation over here, which is we're gonna build this as op2 here together. I'm gonna turn on my layers here. You can see I have the target already. So to get the target, what we do is we play the simulation all the way through to the end, and then this button here, Save Stock to File, will light up. So what I've already done is on exercise 2, I completed the sim all the way to the end, and I used 1,000 tolerances, so I get a good stock file that'll determine the tolerance of your stock file. I saved that to an STL, and then I went File, Open, and I merged that file as my stock. And I've already set this up in my solids as my stock from this feature here, which is a STL model. You can see it up here, STL. And my target is simply my op1 model flipped 180 degrees and put in the vise. I've also already made jaws, soft jaws, for this part, and that's something I'm going to show you on exercise 3. I want to get to the point where we've built up enough where you can be provided a print, put it in the vise for op1, machine it, save the stock to file, make your soft jaws, load your second vise, flip everything over, and continue on. I'm also going to show you how to post code. Some of you have been asking me about that, so I'm excited to show you that. We just kind of have to go in steps to make sure that we all get there together. Alright, so what I'm going to do is I'm going to go ahead and I'm going to apply the operations. I left you guys the chains already, just to give you kind of a head start, because I know you guys have already done that before in exercise 2. But I want you to have the practice of putting the operations back on these chains. And then I'm going to show you how to build a work plane, because we have to have a work plane. That's up here. So we have our work planes right here. And previously we've just been working on XYZ, which is meaning we have nothing else on the table going on. In this case, this is a very good real-world example where we're going to have multiple vices on the machine, and we need to be cognizant of that. If we just write one program for one vice, yes, we can have multiple vices on the machine, but it's not going to be an optimized program. We're going to change to a face mill, we're going to face this part, we're going to do all this roughing, do all the chamfering, and then, oh, hey, we have a second part, so it's going to change back to the face mill, and it's come over here and it's going to do the facing, and it's going to change back to the chamfer tool and do the chamfering. We can do a lot better than that. And I'll show you how to optimize operations, how to drag and drop, and all that good stuff. But first, we're going to go ahead and we're going to apply the operations we've already completed to this part here, and then we'll pick up on our op2 part. So I'm going to go ahead and do that off camera, and I'll be right back. Alright, so I've applied all the operations that we've done previously in exercise 2. I wanted to show you my work coordinate here is set to op1. I put a G54 in there. It's probably something you're more familiar with in regards to Fanuc and Haas. I do run Akumas in my shop, so on my side of things, this would be a G15 would be calling the work coordinate instead of a G54, and then your number would be H01 for work coordinate 1, H02 for work coordinate 2, etc. That way you only call one G code, so G15 instead of a G54, but you can have, H100, H1000, depending on how many offsets you have equipped on your machine. But anyway, so we have op1 G54, and that's set to my work plane op1. So if you notice right here, these are our work planes. And we have our op1 here, which is placed right here. I already pre-placed that. And then I'm going to show you how to place a second work plane and how to create a second work coordinate. That's going to be vital for you guys to know how to do this on your own. Let's go ahead and run through the simulation on this part. Now again, I programmed the first part initially, and then we'll program the second part after we do our work coordinate and work plane building, chain building, and then apply our toolpath with operations. Once we've done that, we can start what I call I consider the fun part is optimizing everything. So when we come down to do a face on here, and then we switch to the other tool, well, before we do that, we should go ahead and face this side here. That gives us one less tool change. Now these machines change tools pretty fast, but it's still a good idea to front load that situation and make an optimized toolpath as possible, especially if you've got 4 or 5 vices on here like I typically do. That tool change time, those savings can add up real quick. But at any rate, so our first part is done. Now again on exercise 2, op 1, this is where I click the save to stock file here. And in this case I only have one stock. I can click OK, and then I've saved it as a file, and that's the stock that I pulled in over here to start with. So that's this guy right here, and I have it on its own layer. This is where layers come in really handy. And then as far as the op2 target goes, I simply took that part and I flipped it 180 degrees, and I made sure it sat down in these soft jaws that I machined in a different file. And I'm going to show you how to make soft jaws and everything going forward as well. Now if you notice, of course, the corners are bigger so that the part is locating on an edge. We typically push this forward and to the left or forward and to the right, but whatever method you would do, you'd be locating against two sides. So you'd be locating against this side here, or this side here, depending on your preference. I like to go forward and to the right and use it as my work stop. The key here is that we're registering against the back jaw, which doesn't move much. It moves a little bit when you clamp it. It's going to move a tenth or so. But it's the most stable jaw to clamp against. And this one here is somewhat floating, so it can adjust for any minor parallel or perpendicularity inconsistencies in the part. But yeah, that's what we'll do is we'll register it against this surface here and then pick a side to push it against. So we'll push down towards here, towards the right. We'll hold it firmly down. We'll apply some light pressure with the vise. Give it a couple taps with a dead blow or soft rubber mallet just to make sure it's seated properly, and then we will torque to our spec. And every part has a torque spec based on the thickness of material that's going to be between the two clamping surfaces. And that's something you'll have to kind of learn by experience. I keep an Excel sheet that guides me on that with known good torque values, and if I need to update it, I'll update it depending on the thickness of the part that I'm working on. But anyway, so next thing we need to do is build ourselves a new work coordinate. So I'm going to go up top here, and you can do it a couple different ways. You can right click on op1 and say new work coordinate. You can right click anywhere in here and say new work coordinate. So either method will work for creating a new work coordinate. You can also edit work coordinates, or you can set active. So you notice that there's a red square around our op1. That's the same thing as the indication around our toolpath, telling which layer that we're going to be working on. In this case, if I go to create a new work coordinate without creating a new work plane first, you see I don't have a work plane to select. So I want to go ahead and create that work plane first. I want to make sure under view that my UVW is turned on. So mine's turned on, yours should be as well, but if you need to turn that on, you can go over here and you can click on UVW, or you can use the hotkeys here, which is going to be Control Alt U. Alright, so if I select op1 from my work coordinate list, or my work plane list, you're going to see our V going up. This is our y-axis. Our U going to the right, that's our x plus, and our W going up, so that's our our Z plus. So UVW is the same as XYZ, if you need to remember that. It's simply an incremental version of XYZ. In this case, we're harnessing that for our op1 and our op2. You can hit F10, or you can click on the icon up here to bring up our work planes. If you notice, I'm on op1 right now, and we also have another window pop up called Modified Work Plane. What I'm going to do is I'm going to say work plane from geometry. There's different things you can do here. We have work plane from geometry. We have parallel work plane, translate work plane, rotate UVW, which is incremental rotation of the work plane, and we have a symmetry work plane. So if this was the same distance from here to here, we could use the symmetry. If we knew this distance right here, which we could find out easily because there's a point there, we could translate the work plane. But the easiest way to do it is going to be to use your work plane from geometry. I'm going to click that, and if you notice in your super secret status window, nobody ever reads, it's going to say select plane first element or reference face. In this case, I want to use a solid. So I'm going to highlight this face, and it's going to put a work plane on it. Now if you notice, initially our W or our Z plus is going the right direction, and our Y positive is going the wrong way. So we can fix this by using our rotate UVW. So we want to rotate our UVW. I'm going to click on that, and it's going to say enter rotation angle around U. Well, if we rotate it around U, we'd be turning this way, and we don't want to do that. So I'm going to say 0. I'm just typing 0 on my keyboard. I'm going to hit enter. Now it's going to say enter rotation about V. Well, if we rotate around V, we're going to be going this way. That would be incorrect as well. So I'm going to say 0 again. Now it's going to say enter rotation around W. Well, I want this V positive or Y positive to be facing 180 degrees opposed. So I'm going to type in 180. I'm going to hit enter. And now you'll notice that my Z positive is still in the same direction, correct direction. My Y positive is now in the correct direction. And my X positive is now in the correct direction. So we've done that, but right now it just shows our work plane as UVW. UVW is a temporary work plane. If you don't save it, you will lose it. So to save it, I'm going to say new, and I'm going to name this work plane as op2. Once I've done this, this is now saved. So if I close this out and I go up to op1, we'll see our op1 is here. X positive, Y positive, Z positive, Y positive, and X positive. I'll change my op2, and we'll say that it did save. We have a Z positive, a Y positive, and an X positive. So that's great. So now that we have this op2 work plane, we can create our op2 work coordinate. So I'm going to go back over here, and I'm just going to right click anywhere on the canvas here. I'm going to say new work coordinate. I'm going to call it an op2. I'm going to give it an increased coordinate number. So on the Faneker Haas, it'd be G55. On my Kuma control, I would have a G15 up here, and I would have an H01 or H02 in this position here. So if you notice, it already knows I created a work plane op2, and I already have it active up here. So it selected it for us. So that's correct. I'm going to go ahead and hit OK. And now I have an op2 work coordinate tied to my op2 work plane. That's great. And if you notice, it's highlighted, so that means anything I create from now on is going to be placed under this work coordinate. So I'm going to go ahead and go to my chain layer. Alright, so there's actually a couple of different ways we can do this. Now, because our model already has the chamfer on it, if I highlight the face and I go up top here to create features, and I go over to my auto chain, again making sure that I'm in the chain layer, and my op2 is highlighted, it will create a chain. Now this chain is going to represent the face, and it's going to pick up on the chamfer, and it's going to call it a draft, which is fine. We can still get the information we need off of this. The other way we could do this is a little bit more complicated, but I'll show you. So if I wanted a true outline of the part, I'll go ahead and turn off my soft jaws here and turn off my vise so I can see a little bit better what I'm doing. I'm in my op2 still. I could go up here to a function called part profile. Now before I do that, I'm going to switch to my geo layer because I'm about to create geometry. If I go to my part profile, give myself a little bit tighter tolerance, and I grab this body here, Once I hit OK, I'll go ahead and I'll turn off my target. You can see I have the geometry. So it's just like shining a flashlight down on a part. The shadow is what it picks up on. So I could take this and go back to my chain layer. I could turn that into a chain. I could call it face. I'll call it back face just to keep separate. And if you notice, it doesn't have the draft on it. Now, either way will work. If you do it this way, you just need to add your chamfer angle and the depth. All right. If you do it the slightly easier way, but you have a little less control over it, right? That still works too. I'll turn my target back on, and I will highlight the face, and I'll go up here to auto chain. Still going to give me a chain that'll work for my face, and it will pick up on the chamfer, but again, it's going to consider it a draft or an angle. That's fine. It'll still work for us. But either way will get you where you want to go. I'm going to go ahead and name this face. I'll name it back face, just to be consistent. Put myself on the toolpath layer. See, I should have put that chain. If you ever build something on the wrong layer, you can change it real quick under general. I'm going to put that on the chain layer. There we go. And we do have a bit of stock on top of this. So I'm going to build a facing operation. I'm going to do a roughing operation using climb and conventional or zigzag, because that's the quickest way to remove the material. So I'm going to go up top here to solid mill traditional, and I'm going to go to facing. Alright, so I'm going to create a rough face operation. I'm going to use zigzag. It's the most effective way to remove material. I'm going to leave myself 25 thou for my floor finish. And I want to make sure that I give myself a starting depth, a negative starting depth, right? So that's going to have it start above the part. So let's try a 1/4 inch and see if that gives us enough starting height so we're not starting too far into the part. What you would do is you would measure the part as it sits in the vise, and you'd be able to determine how much material you need to remove off the bottom of the part, and you would enter that here as your starting height, and then would proceed to make cuts from that height. Alright, so that looks good. Let's say OK. And let's go ahead and check it out. Alright, so you see how it didn't cut anything there? That means we're just a little bit above it. I'm going to take a different view here. Now let's try the right side instead. There we go. And you can see we're pretty close. I'll actually leave that because there's a chance we could have, your stock is not perfect as it gets extruded, right? So there could be a little bit of stuff in the bottom that's a little bit higher than we actually think. I'll leave it and we'll just watch it clean up. That's fine. There we go. Alright, so we cleaned that up. We left 25 thou on there. So now I'm going to go ahead and I'm going to put a finish face on that chain. So I'm going to highlight the chain again. I'm going to go back up top here. I'm going to go to my facing operation, and I'm going to call this finish face. My strategy this time is going to be climb, so it's going to make multiple passes in the same direction. That's going to get you the nicest finish on the part. My starting depth is going to be 0, because I just want it to make one pass. Stock automation is still going to be no. And my links, nothing's changed there, so I'm going to go ahead and put this in. Alright, there we go. So the only thing we have left here is the chamfer. Now if you notice, we don't have a ton of room to clean that chamfer up, but that's fine, we don't need a ton. It's always a good idea to hold as much of your part as possible for the second op. simply because you're relying on soft jaws to hold it in place instead of our serrated jaws that we have over here. Alright, so we're going to want to put our chamfer on there. So I'm going to go ahead and go to contouring operation. I'm going to call this chamfer 45 degrees. I'm going to use my drill mill. These speeds and feeds are fine. Strategy, I'm going to take one pass. If you wanted to, you could do a spiral move. I'll do it just to show you what it does, but it basically eases into the cut. For example, if I was taking a 5 thou chamfer, I wouldn't have any reservations about doing it in one pass. Anything more than 10 or so, I generally like to do in a spiral or a 2 pass here with, let's say, a 1% step over. It just looks better that way. Total depth, I'm only going to go down 25 thou, and that's all I really need to do. I'm still going down 2 times the depth of the chamfer. Easily, this is a 10 thou chamfer, so 2.5 times the depth. Everything looks good here. Make sure your stock animation says no. Under advanced, nothing there. Links, pretty standard stuff. I am doing a little bit of a crossover. I can make that 25. That doesn't have to be 50. That's a bit much. And that's just going to make sure that you can't see where the tool enters and exits the part. I'm going to say OK. I'm going to highlight my chamfer here. So you can see with a spiral, it's actually going to start quite a bit out from the part, so that's a bit wasteful. I'm going to turn that back off. There we go. And because the chain starts over here on mine, this is where this starts. It's fine. It's a little bit easier sometimes if you need to start on an edge that's not near a vice jaw. I've had some parts I've done where I've actually ran the chamfer tool through the part and through the vice jaw at the same time. Not the best situation to be in, but in a pinch it does work. But that would be one of the times you'd want to start obviously between the jaws, not in one of the jaws. That way your entry is in a cutting motion, not a hasty plunge per se. But it does happen sometimes. That's why they're called soft jaws, right? Only crashes on the first try. Alright, so we did a chamfer there, and I'm going to show you that again, and I'm going to zoom up on the side so you can see how much room we actually have to work with for clearance. So it's going to come in on the side here, and I'll get a better angle in a second. And it's going to walk itself around, and I'm going to switch to, I believe, the right side view. Yep, there we go. And you can see what clearances we're working with here. So pretty close there. If I wanted to, I could back that off. You'll see it go up a little bit there. And this is pretty common where you kind of have to tweak your operations as you go. Usually nothing's going to be perfect on the first go around, unfortunately. But that's why we learn how to do things in multiple scenarios. Alright, so that's great. I don't see any problems there. And the part is done. Now the only downside inside of a spree when you have two of these guys here going on, when I go to comparison, it still defaults to the first operation. So just run everything to completion and just send me a screenshot of the completed files, because it's not possible for you to do a comparison in this instance. But yeah, so that's how you make the part in real life, and this is how I make parts every day. So if we go to operations, you're going to see we have a bit of a fandangle here. We have a rough face here, finish face, and then we do all this stuff here, and then we go to rough here, and then finish here, and then we do a chamfer. Well, we can do better than this. So I'm going to take these two here, and all I did was I held down my control key, right? So I hold down control, and I clicked on both of these, and I'm going to hold down my left mouse button, and I'm just going to pull these up. I'm going to put them right there. So now it's going to rough face this, finish face this, rough here, and finish here. And then it's going to do the chamfer work over here, after it's done all this, of course. I'll do the chamfer here, chamfer here, chamfer here, and then it'll jump over here. So because we have different heights, right, we want to make sure we simulate this, make sure that there's no, oh, I didn't retract high enough before I moved, any of those whoopsie situations that occasionally does bite us. So I'm going to go ahead and run this all the way through. There. Hey, no problem there. All right, beautiful. So we have a complete part. So every time we open the door, we take a complete part, except for the first time, of course. We take a complete part out of the right side vise, and we take the left side vise, wipe it off, blow it off, flip it 180 degrees. Typically, though, I try to flip it along um, side to side, just because of the way the mill works. But when it's cutting left to right like this, if there's any taper in the part, um, your soft jaws are also cut the same way. So when you flip it, that taper nullifies itself out. But if you flip it end to end, um, if you have a narrow side, the narrow side is going to get more narrow. It's kind of hard to explain, but you try to flip side to side, get you better results if you're trying to hold tight tolerance thickness. But yeah, so anyways, I'm glad I got to show you that. Almost forgot. But yeah, that was one of the key takeaways I wanted to give you guys was work plane creation, work coordinate creation, additional operations, and then optimization of those operations. And again, we're going to start taking off the training wheels a little bit, so the next time I'll have you guys make the soft jaws, and then eventually I'll even have you guys place the vices too, so you get to learn how to do that. As always, if you have any questions, please leave them in the discussion forum, and I'll be happy to help you guys out. Take care, have a great week.